They are 4 times more likely to be involved in the youth justice system, 5 times more likely to be excluded from school, 40 times more likely to end up homeless. Looked after children are amongst the most disadvantaged people in the United Kingdom. They are also more likely to have mental health challenges, as about half of them have been diagnosed with some form of mental illness. And they are more likely than their peers to have special education needs, as 59% of them are seen to have special education needs by the time that they're 11 years old. That's a lot. But the authorities in this space are not passive. They are actively looking for ways to improve the experiences of children in care. And by children in care in the UK, we are talking about all children that are looked after by the government for a period of more than 24 hours. So most common is foster children, looked after in a home with maybe parents that own the home. And then we could have residential care for more organized homes with multiple children, more adults that are trained to take care of children. And then you could have supported. Supported placements are for older children between 16 and 18. In the UK, looked after children are between 0 to 18 years old. So 16 and 18, you're going towards independence and you're just being guided towards that independence. And it's in order like that. Foster is normal, more or less. And then residential is when it's an escalation if you're moved from foster to residential. And then supported is just a normal progression because you're growing older, and when you're 18 years old, you would leave care. However, if these children do not have a good experience in care, they end up to have really poor outcomes in life. So the authorities are actively looking for how to improve the experiences of children while in care and to increase their chances of succeeding when they leave the care system. However, they lack access to timely insights on what is working, the effectiveness of interventions, and the updated areas of need. As a matter of fact, sometimes insight comes 6 to 8 months late. And this is not a typical case where you say there is no data. No, instead, there is a lot of data collected. We are good in the UK at collecting data. There's a lot of data collected about children in care. However, there is little insight. This is because the data is dirty, summarily. It's not trustworthy. So you could get the analysis of, oh, these are the main movements of children, or this is how many children are entering care or leaving care, but summarily you cannot trust it 8 months out of 12. And that is because the DFE portal that is used to check the integrity of the data is available just once a year. DFE is Department for Education, and they are the part of the central government that these local authorities have to give the data to every year. So for some context, in the UK, we have various local authorities that collect data about the children in their care. And then once a year, we call this statutory returns. So the government says these are the kinds of data you should collect, these are the kind of variables we want to look at. And then every local authority collects that exact same kind of data and then uploads it and gives it to the central government for summary reports every year. However, when I talk about dirt in the data, I'm talking about, we have the usual nonce that is in everybody's data, but I'm talking about things like the dates of adoption of a child cannot be before the date of birth of the child. Like, you have to be born in order to be adopted, of course. But then we have less obvious things like a child that is less than 16 years old cannot be in supported placements. So if you look at a child's data, data from their check-in, and you realize that they have been labeled as being under supported placements and they are less than 16 years old, then that's something to flag. So you have logical things like that and more obvious things. However, there are a lot of rules, actually, and these rules are determined by the DFE. 287 last time I checked. So sometimes they add more rules to things that should not happen in your data. 287 rules, about 80,000 children in care in the UK. It's not practical for human eyes to go through all that data and spot those errors. So we have to look for some form of automation. That is why they have to wait for the DFE portal, which is available only once a year. That means that 8 months out of 12, just have a lot of data that, well, they cannot use. And then when the DFE portal gets available, we have this 3-month period where everyone is rushing to correct their data. So it's a layered structure this way. Social workers work directly with the children who are in care, and then you have social analysts analyze the data collected by social workers. Then you have commissioners, the leadership, the authorities that actually make the decisions that change things or have to relate with the with the central government. Okay. So what happens is that this social care analyst, the ones who just work with the data, when this 3-month window comes and then the DFE portal is available, what happens is that, okay, if they spot, let's go back to our example of a child is 6 years old and marked as supported placement. Okay, that's an error. What they have to do is they have to call or contact the social worker who took that value and then get them to correct it, to actually find out what the correct value is. That's a very time-consuming process to do anyway, but having to do that maybe 8 months after the value was recorded, when some of these social workers, the people who collected the data, might have moved on to other jobs because this sector has high attrition rates, so people move on often. So sometimes the person that collected the data is not even present. And then it's so much work that when this window comes, this collection window comes, it's the main thing that analysts do, nothing else. So we have analysts that are doing less of analysis and more of data cleaning. Just so little insight in the sector. So we had this study with them. I work at social finance. I will talk about it later. But we partnered with a few local authorities to see whether these pain points are common across the country. And when we found that, okay, the main thing was data could not be trusted. So there were two things we could do. We could say preventing human error at the start of the data, of feeding the data into the systems, into the various case management systems, or helping them to check the errors. And this was a faster way or more logical first step in getting impact, I would say. So we decided to create an error checker that is available throughout the year to help them to see the errors in their data day by day, so that you could actually just check the data values that came in yesterday and flag that this is probably wrong. Okay, but this came with an interesting set of problems too. Because, of course, we were like, error checker, cool, that's what we are creating. That will probably solve the problem. Everybody is happy. But then we realized that we exist in an interesting sector where to scale a tool across the UK is an interesting thing to do. And that is because in order for you to process data in a tool, you need the data and the tool to be in the same place, obviously. But then to make that happen, two things are involved. They could either give their data to us, or we could put it on the internet and then they upload it on the internet. But then this is extremely sensitive data. So we have GDPR in the UK. That was not possible. Like, you have data about the names and the locations of these children live, and it was live. Like, there was nothing you could tell anybody to get that data on the internet for any reason. So that was not an option because of governance issues. Then the next thing was, what if we could install the tools in their computers, the local analyst computers? I mean, the social workers who work in the local authorities. What if we could install the tool in their computers so that they are able to use it even without the internet? And then that brought up another interesting blocker, because the UK is very decentralized. So we have the central government, and then we have the local authorities, which are about 151 local authorities. And each local authority has its IT department. And there's no IT department that approves anything for the rest. So we would have to go through each IT department and get them to give approval for the installation of the tool. And they are giving approval for the tool as is. And then whenever we make a big update or a change in features, we would have to do that again, 151 trips across the country. That was not a viable solution. We wanted to spend more time in building and iterating and creating something that will improve the experiences of people that are trained to find insight on how to improve the experiences of these children in care. So this is a summary of the problems that we have. Now, something else something, not a constraint, I would say, but something else was required. The tool had to be in Python. And that is because the main goal was analysis, and Python has this full scientific stack that makes it really, really adapted for analysis. It's like my preferred language for analysis, and tends to be many people's preferred languages for analysis too. And then another thing is Python was beginning to gain popularity among local authorities. So its reputation went ahead of it. So if we wanted to build something, local authorities mostly use Excel now. So you know how people are not so embracing to change sometimes. So Python was something that they were already embracing. So that we wanted to step on that. So it had to be in Python. But we wanted to have the user interface, we wanted to have a good user interface. We did not want to sacrifice the user experience. So we wanted to build the front end in JavaScript too. So right now, we cannot get users to install our tool. We cannot upload it we cannot get them to upload their data on the internet. The backend has to be in Python, front end has to be in JavaScript. We needed a way to compile Python in the browser without losing any of its data science capabilities, while allowing the user to run the program in their computer without uploading their data to the internet. Pyodide. Perfect. So we came across Pyodide. Pyodide compiles Python in the browser. So it basically, it compiles Python into WebAssembly, which is like bitcode for compiled code, and then that's like portable enough to be shareable on the web. And then when the web browser loads it, it compiles it into native code. Essentially, Pyodide runs on the Iodide model. It was launched in one of these PyData meetups. And the Iodide model allows the UI to be connected directly to the kernel without the need to pass through the server. So we are able to run the user is able to run the whole setup of the tool without the need of the internet. So the way it works is that the user connects to our link on the internet. The Py scripts get loaded into their local environment. Then they can go offline and run the validation of the tool. We don't touch their data. And we have achieved an error checker tool scaled across the UK. So that's it. First problem solved. Now, the second is I work at a not-for-profit who has a how would I say? We have, one of our favorite things to do is to make ourselves redundant. So when we work on something, the idea is that we train someone to do it so that we don't have to do it anymore. And then we have to look for something else to do. And the question when we started building this is, what happens to it in 5 years, in 10 years? Who maintains it? Who fixes bugs? Who updates the features? When the DFE releases new rules that define the integrity of the data, who adds those rules to the tool? And that's a question that we pondered about for a while. And we decided on in whose best interest is the life of this tool. And it was those same children's social care analysts. So we brought them along with us through this journey. We trained them in Python code, like from scratch, how to code in Python. Built like the larger infrastructure of the project, testing, joining the back end and the front end. And then we collaborated them as they built the tool along with us. So the 287 rules were coded one by one with the help of these children's social care analysts. So we were teaching and giving them a chance to practice in real life. But this came with added benefits too. The fact that they learned how to code not just meant that we had someone to maintain it when we were gone. It also meant that we had domain knowledge. It means when we would look at a rule and it doesn't seem obvious to us what that rule means, we had someone to ask. These people, so we have somehow had the opportunity to have a tool that has the possibility, I would say, of becoming more accurate, because you have the people who work with this data day by day know exactly how it's going to look like. And then another thing is, they know how to code, and that just has its own advantages, because the whole idea is that they spend so much time cleaning data instead of getting insight. But then there are a lot of things that they spend so much time doing that might not be obvious to us, but if they know how to code, they will probably start automating those little tasks that they do. So it has like this overflow effect, which we're looking forward to see, and we have started seeing already. So far, this has been the impact of the tool. We are committed to working on things that have an impact that we can see linearly, not doing something that we think will do another thing that will create impacts. Yeah, we like to see what exactly are we doing now that will improve the lives of people. And so far, we have done an estimate to see that this tool will save 130 days per year per local authority, for an average local authority. So they will suddenly have all this free time. People that are best trained to work with children in care, people that have the passion for this, suddenly have 130 days to do whatever they want to do with it. And we are looking forward to see what they do. Because the truth is, what if those who have the knowledge suddenly have the time? And that's what this project is enabling. Another thing is, it's been scaling organically, and we have 70 out of the 151 local authorities using the tool already, so people are practically just like telling their friends about it. So it's receiving a lot of love and appreciation, and we are really happy to have created something that is useful for the community. And we have this analyst community now that can write Python code, can identify malfunction, and can fix bugs. Recently, we've had them actually identify bugs, and then we'll say that, okay, we'll get back to that later on, and we'll come back to the repo, and it's been fixed already. And wow, it brought so much rejoicing when that happened, and it kept happening, and it's like, it's a thing that we look forward to at work, just seeing those changes on the repo. So now I'll do a demo of the tool. Can you still see my screen? Okay. So this is how it looks like. This is how it looks like. This framework is the gov.uk framework. It is mostly used when designing tools that have to be used by the public. So that's how it looks like. So they come and click start. I'll do like a very simple demo. Click to upload files. This is fake data because I don't have clearance to that data right now. GDPR says that you would have data only while you're using it, and if you are not using it, then you have to give it away. So we couldn't just keep that around. So this is it, and then we click validate. So you could actually just choose the particular rules you want to check, or you could validate all of them. This will require some patience, but let's click validate. That's going. Give it like a minute, so don't hold your breath. Like when that Pyodide, we are still working on how to optimize the speed of this experience, but that's loading. Oh, I wanted to do a demo of it offline. Maybe I should do that again. But I'll do it the second time with fewer rules. But that's how it works. But while that loads, I would also want to just mention something small. Like you can see, you can't see. There's a button below that says download 903 CSVs. So we have these monthly meetings. Okay, it has run. Let me talk about this before I go back to the CSV. An example is, so it flags the things that do not look okay. So you see it has flagged 2 as sex, and it has flagged the mother field, and that's just for the 801 file. If I go to the episode file, then it flags more things, missing file, so like that. At the top, that's the header file, yeah. So an example of the errors, so it flags the errors in red, the particular locations generating the error, and then you would see the error code, like 165, data entry for mother is invalid. You see, mother is missing, and it has to be filled. It has to be filled with a value, even if that value says that the mother is not known. There's a code for that. And then child is looked after, but mother field is not completed. So this same data entry has flagged to rows, two error codes. So that's what the analysts do. So we have basically replicated their error checker tool, but in a way that they have access to it every single day, every hour or minute. And I wanted to talk about this CSV converter. Let me just open it again. So it's 903.data to insight. Okay. Data to insight.org, start. A CSV, so that's it loading the Python. So when it loads the Python, then I can go offline. Okay, and then we could load that again while I'm talking about something else. So just to talk about this that has appeared here. Come on, why does that? Okay, it's more visible here. 903 CSV Converter. That just came up from a very interesting conversation we were having with the analyst, where they said that some people have their data in CSV form and some people have their data in XML form, but most people want to have their data in CSV form. And the question was, could we have something that converts XML to CSV? Now, for us, that seems like an obvious thing that should exist already, and it probably exists on the internet. But then coming back to the constraints of this particular space, where they have this extremely sensitive data, so the fact that something exists on the internet doesn't mean that they have access to it. So that was just a little addition that we added to the tool to enable them to put in their XMLs and get out CSV. Yeah, that's something more basic. Then I'll leave this, so this is offline now, and then I'll just load it. I'll load the files again to run as I continue the presentation, and then we'll come back and check on it. So you could load as CSVs. Maybe let's try with XML this time. Oh, come on, I deleted my XML files. CSV then. Yeah, there you go, then validate. Okay, so while that goes on, let us continue. Demo has been done. Now, at the end of the project, we were reflecting on, just reflections. We tend to do that a lot at the ends of projects. And we were like, we now have a community of domain experts that can code. And we have the ability to process data at scale. We have constant data structures. What more could we do with this? It seemed like we could do more with it. And we are thinking of, could we possibly have the recipe for an analysis platform? And I would just go ahead to talk about what that could look like. So far, we have done the 903 is the name of the quality of the looked after children data set. It's called SSDA 903. So we have done the ingest and validation of that data, and we have done an error checker for it. But then it's a really big space because there are like 5 statutory data returns that have to be done for children in care or looked after children. And then across all areas, there are about 100 statutory data returns that have to be done per local authority to the central government per year. So what could we do with the infrastructure that we've created? What if we could do the same? What if we could create an error checker for children in need data, for school data, special needs data? And then what if we could link all that data together? What is it going to enable us to have? Could we possibly be able to do more types of analysis? Like, we could do exclusions analysis now, understanding what causes children to be pushed out of school. We could do understanding of missed risk. So children in need is like extremely vulnerable children. Are there some signs that we should have seen that we didn't see that caused us not to be able to give this child help when they needed it? We could look at that, and we could look at ways of preventing that, or just statutory return analysis in general. And the interesting thing about this is that exclusions analysis has been done already. We did that as a project, so we actually took the real data and combined it we did the cleaning and combined it. But it's not scalable, but it's just something that we have. But we were not able to share that. We just shared the PowerPoints, and we created a report that was published, and people just saw like the static nature of it, like this is how it looks like now. But now that we have Pyodide, we could create this into a live format. This same cleaning and joining, we could create it into a live format that year by year, people are able to see analysis of exclusions and say, okay, we said that we will focus on doing this to prevent children from leaving school. Is it working now? Are they still leaving for the same reasons? And then race equity analysis, maybe if we want to analyze special needs education or children that have special education needs, SEN. And this is where we are now. Now we've created the 903 return. We have the ingest to validate that this is actually a 903 file. Because the way it works is that even if you upload a file that is not really 903 but has the columns of 903, our tool is able to pick the columns that it wants out of it, name the file correctly, and then continue the process. So we have quite a robust ingest process. Then we have an error checker, which I showed you, and then the visualization in the front end. And then this is what we're looking to build. Actually, we have already started plans for SIN. SIN is children in need. So that's extremely vulnerable children. So this is where we are now. We are starting SIN in August. But right now, what I am working on is a demand modeling tool, a forecasting tool to help local authorities budget for the future, because there's an influx of children into care, but local authorities are not able to plan appropriately because they don't know how many children are coming into care, how much it's going to cost relative to inflation, and all the other variables that affect the ability of us to support the children that are most in need in our society. And the project I'm working on now is a demand modeling tool, a forecasting tool that takes into consideration all the movements of children within care and into care and out of care. And it's something that we already did in Excel as an Excel tool, and of course was not able to scale before because we couldn't get to scale. We'd need the internet in some form, and we couldn't get users to upload their data to the internet, and Pyodide has just enabled that. So Pyodide is allowing us to scale so many tools that we've already created and we're just sitting in the cupboard somewhere, and it's opening up far new spaces, bringing more opportunities, more partners into this space. And another tool that we're working on is, I will talk about our tools, I'll talk about our areas of work in general. At Social Finance, it's a not-for-profit that works on high-impact areas. So we work across a range of areas: adult social care, housing and homelessness, housing and homelessness, adult social care, improving the experiences of children in social care, health and employment, helping people with mental challenges fit into work and stay there, because we believe that the only way for people to learn how to work is to work. But another tool that we created is the family context tool, which has to do now with the social workers. So you remember, we have the child, we have the social worker that actually meets the child, and then we have the social care analyst that analyzes the data about the child. So social care analyst is what the tool I just talked about. That's what it was created to help to make their systems more efficient. And then now the family context tool is for social workers, those who actually go to these children's houses and hold these children's hands and make the decisions about where the children are going to stay. And so far, they would spend about 3 hours finding information about the child. Okay, you have this far uncle or auntie somewhere. Main thing is, are they safe for you to go and stay with them? That's the question that we want to answer. And family context is a project that links multiple data sets. We are averagely saving 3 hours per case, so that 3 hours is spent with the child instead of searching for data. We are bringing all that data into one space, such that by a simple search of a child's name, you're able to get information about the child's circumstances. We have linked adult social care data and housing data, and it's customizable, so every local authority decides what kind of data they should be linked. But when we started with Stockport Council, those were the two main ones that were present. And then exclusions analysis, we do deep dive analysis sometimes. So sometimes we build tools, and sometimes we just get curious about an area and do a deep dive into the area to find out, well, are we making any assumptions here, or is there something that we've been ignoring so far? And we kind of did a deep dive into exclusions from school. So exclusions, I'm talking about when the authorities ask a child not to come to school anymore as a way of punishing the child. So what happens is they would do temporary exclusions. So leave school for 2 or 3 days and come back. And then sometimes you do permanent exclusions. We never want to see you again. So we are trying to prevent that, because children that are excluded from school have very bad outcomes in life if you have been excluded from school at some point in your life. So when we made that connection, we decided to dig into how to prevent that from happening. And we were a little bit surprised, because so far the assumption is that boys get excluded more from school. And then we found that girls get excluded equally in some, under some variables. For example, boys get excluded formally from school, like go design a document or something, but girls get excluded as, well, managed transfers from one school to another, or long periods of absence, or just, it's never formal for girls. But when we found that, it kind of brought some attention to the space, that maybe we shouldn't direct all the interventions towards this particular set. There might be another set of people that might need help equally. That's me, and you have more links here in the slides. The full discovery report, when we entered the space and we had no idea how to improve children's social care, until when we decided that an error checker might be the first good thing to do. That's in the discovery report. It's really nice to read through, and all our code is open source, it's online, you could see it there. And then social finance projects in general, that's the repo for that. And children's services project is another related repo. To read about this project, you could look at that blog, and to read about Pyodide and the scientific stack in the browser, you could look at that blog. Thank you.
Thank you very much. That was excellent. We've got a bit of time for Q&A now. Yeah.
Okay.
Thank you very much for the presentation. It was super inspiring.
Oh.
So I have like a couple of questions. One, I don't know if you've looked into PyScript, which apparently builds on top of Pyodide, so maybe it could save some work, but I'm not exactly sure. And on the other hand, I don't know if you could comment a little bit more on how you're teaching like social workers to code, because I find that super intriguing, and like to what extent they're able to like do data analysis, or what tools they use, or anything like that.
Okay. So we got the volunteers by just saying, well, we want to build this tool and we want to teach people a new language who is interested, and we got like a whole lot of people interested. And then initially, for them to learn how to, we taught them basic Python, the base of Python, and then we taught them the things that they needed to build the project. So it was recorded videos at the start, where you go through these Python modules to get an idea of what programming is and what the language is, and then we had these videos to teach them how to create an error function. It was PyTest, basically. Every role was created as some sort of PyTest function. So got them to learn how to do that. And as they progressed through the project, then they started getting interested and seeing maybe the ingress.py file, how does it work? So it was a very gradual process. And people that get more interested get to dip their feet into the water a little more. And everything was done on GitHub, so you would actually see their pull request there. Yeah. That's how it's working. It's an ongoing process, because we are taking them along to this SYN project starting very soon, and we want to onboard a new set of analysts. The plan is to totally be able to detach ourselves from it in 3 years or so. Mm-hmm. Okay. Wait, her hand was up first, yes. Sorry.
That was a great presentation. My question is a bit generic. So with this tool that you've built, what are your challenges that you're facing currently, especially because you want to go ahead with your analysis for children in need? So what are the challenges that you're facing to make this more, put in more data science to it, to extend your use cases?
Okay. First challenge, of course, you see the speed of loading. We could make that better, hopefully. But the idea is that we aren't the ones who would do the analysis. The whole idea of the community is that the analysts who normally do analysis on Excel, move that knowledge to Python and then collaborate on it using the tool. So we do analysis and publish reports, but we want to make that more wide scale, where the people actually working with this data day to day get to do the analysis and share. Problems that we are facing so far with doing analysis, nothing comes to mind exactly, because this was a main blocker for a whole lot of time, and that is resolved already. I don't know, I find it hard to remember problems if I didn't write them down, yeah. I think it's harder, okay. We could just do it.
Thank you so much for the presentation. I was wondering if you had any challenges around being able to convince people that the data are not actually leaving the computer, and how you manage some of that.
Yeah, I guess it's time for me to just show that has actually run successfully. It was that has run successfully offline. You could see I'm still offline. It was very useful for us to actually demonstrate that if I go offline, when you're offline, everybody knows that you're cut from the internet. The tool still works, because it's a fear. These people work with very sensitive data, and they are very careful about GDPR. And the fact that it can work offline was a very big banner that helped them to onboard themselves to this project, yes. And we got it tested by external people.
Cool, so we've got a couple of minutes, maybe time for one more question.
I think his hand was up. What's okay now? Yes.
Yeah, I was wondering, how do you, if you worry about people looking to the errors and trying to solve all of them, even when they don't have the information. So, for example, in the case of gender, you can have an ambiguous situation that people put that number there or something, meant that was ambiguous, but then somebody else see the error and try to fill with something that needs to match there, or if the local authorities start to pressuring people to get rid of all the errors, and they start to filling information that's inaccurate, if you worry about that happening.
This is an error checker, so they don't correct the data here. Yeah, so this just does what the DFE error checking portals was supposed to do, but was available only once a year. So we started by solving the base problem, making that available throughout the year. But they have processes in place at each local authority to prevent people from randomly changing important information about children. So those same processes exist. We haven't boycotted those. Yeah, you had a question.
We've got 5 minutes until the next talk, so
Okay. Okay, I'll just
very interesting, and can we say a big thank you, and hopefully there'll be some more information if you want to share it on the Slack. If you're not on there, let me know.
Yeah.
Everyone else, if you're having any trouble with the Slack QR codes, there is another one circulating about. So thank you very much.